Hello everyone, my name is Andrew Chabot, and today I will be demoing the SHA-1 visualization using the hash function visualization language. So I'm just going to be running this through PyCharm, but you can do the same on in a command prompt or whatnot. So my the hash function visualization depends on a few packages in Python. The main one is the Piglet package, and that one is used to actually display the things that are going to be visualized. So just the basically the visual package there. There's also a few like NumPy collections, things like that, but those are mostly standard packages besides Piglet. All right, so in our little terminal here, you can run Python 3 and then hfvl.py to pull this up, and then it'll tell you to enter a file name. So for this demonstration, we're going to be visualizing SHA-1. So we will run SHA-1 here. So it says file found, and we're loading this visualization. It'll take a few seconds here, mostly to do pathfinding of arrows, but now that we have run it, we see this window pop up. And this is our main SHA-1 visualization window. So you can see here we have the main like control flow. The words are going to be coming in up top here. They're going to be output down here. You can see all these boxes here that are basically operations and their outputs. Now on the right side here is our more descriptive boxes. So we have the current f function. So that's the function that's going to be going on here. The current round constant, which is going to be the value that gets populated in this box here. The message schedule, which is where this expanded word is going to be coming from here. And in the lower right, we have this big description of events to give us more context of what is going on. At the bottom here, you can see we have the play button. And this will actually start playing our frames at a given speed. The speed is shown here. These numbers on the left and right will decrease between 0.1 times speed, and we can increase all the way up to 10 times speed. But we'll just set it at 1 times for now. We can see we have more manual controls here, just for going between previous and next frames. This will just manually increase and decrease the frame number here. Next we have moving in between rounds here. So obviously we start at round 0. There's 80 rounds of SHA-1. So if we want to skip ahead a few rounds, we can use these buttons here. And lastly, we have the restart button, and we can restart all the way back to frame 1 by clicking that button. All right, so now that we know how the general design of this window is, let's start exploring what happens in SHA-1. So let's just manually move through some frames here. So we see this is the population of the initial word values that come up here. So these boxes are now populated with their respective bytes. All right. Our message schedule here just was updated. There's nothing changing here, but this will update every round to make sure it's displaying the proper message schedules that should be coming in based on our round. So for rounds 0 through 3, this will be like the same image as it goes, or sorry, not the same image, the same text. As we move into round 4 through 7, this will update to have the message schedule for those rounds. All right, so next we're going to be transferring the values from word 1 to word 2 of the next round, word 3 to word 4, and from word 4 to word 5 of the next round. And you can see we use this blue here to designate that these values are being transferred. So now we can step through a little bit and we see, okay, these values have just simply moved into that area. So now that we've done that, we're actually going to be taking in words 2, 3, and 4 and taking these in as input to the f function. And now this f function is going to run based on these inputs. But okay, so what's actually happening with this f function here? We can see that the text that's going on up here. We're taking W2 or W3, and we're ORing that with not W2 and W4. So that's interesting, right? But maybe we want to see that more in depth. So we can actually click on this box to see more details about what's going on. So that's what we'll do here. So we click on this box and we get a new window that gives us a visualization of what's actually going on in this f function on the bit level. So we can see this is W2 and W3, and they're getting populated with the actual bit values versus the previous byte values here. And we'll be able to see what's actually going on with these operations more clearly looking at bits versus bytes. Now next, we can see that our W2 and W4 values are also getting populated down here. Now we're going to take these as input to this OR function, which is going to give us an output that's actually just all ones. So next we're going to be taking this value and running it through a NOT, and we get this NOT W2 value. We'll AND these two values together to get this output, and finally we'll OR these two values together to get this output. So we can see, okay, this is just all one, so we expect this to be FF. And so we can see that our F function produced just all F byte values here. All right, so now we know about that F function. Let's run through addition mod 2 to the 32nd. So we're taking in this F function output as input and word 5 as input as well. And the style here is that we take green for input and we use red for output and basically like functions occurring. And blue, as we talked about before, is generally used for just changes or like transfer in value. All right, so let's open up the addition mod 2 to the 32nd bit visualization. So this is going to be very similar to the style that the F visualization is in. And you can see we're taking in the byte. We're actually transferring it to bits instead here to give an idea of what's happening. It's almost just to make sure that the input bytes actually match in here versus the parent visualization here. All right, so we can see these get populated here, and let's just play through this. And I'll kind of talk through it. So we have these two inputs, they're being added together, and we get this output. We can see that there's an extra bit that snuck in here, so we'll take this modulo 2 to the 32nd, and we'll now get this output here. And it basically just chops off this leading 1 here, and we get the output byte of C3, D2, E1, EF. And we now have that as the output there. So that's what all of these addition mod to the 32 blocks do. They're all they're all identical to each other. So let's move on to something that's a little bit different. And this is going to be the 5 left bit rotation here. So this will take word 1 as input, and we'll do a rotation here. You can see this is the output that we're going to get, but we'll look at this sub-visualization to confirm that. All right, so very similar setup here. We get this byte input, transfer it to bits, and we're going to do a bit shift here. So the bit shift 5 to the left means that this value here with all the ones will move into the front, and these first 5 bits will now be present down here. So you can see 1, 2, 3, 4, 5. Those move there, and everything's shifted up to take its place, and we get this output byte here. So that seems pretty straightforward, and we'll take that with our previous addition output and add those together, again mod to the 32nd to get this value here. All right, so let's keep on stepping through, and we will take in our first byte from the message schedule here, and this will be the D7, DC, 7B, B2. And we're just taking this from our schedule up here and plugging it in. And again, same process. I'm not going to step into all these addition mod to the 30 seconds. Um, but we're going to do same operation, get this output here. All right, now we're going to take in our round constant, and this round constant won't change until we hit round 20. So for the first 20 rounds, it's all the same. It's this 5a value here. Again, we'll take this addition and plug it into word 1 here, and we get our output for word 1 in round 1. All right, so the last operation that happens in a SHA-1 round is that we take in word 2, round 0 as input, and we're going to run it through this 30 left bit rotation here. So we can open this up, and we see, wow, this is the same setup as the 5-bit shift left visualization. But you know, just to see what happens here, we're taking it, transferring it into bits, doing a bit shift here. So a 30-bit left shift is essentially the same as a 2-bit right shift. So you can see these two bits here are now just in front of the value here, and everything else has shifted over to the right. All right, so then we get our byte output here. It's kind of important to note that these boxes are meant to be read from left to right and then downwards, just to make sure. It's just like you're reading text, basically. That it's just that not everything would fit going if these boxes only went sideways, because bits take up so much space visually. All right. So now that we have that, we can transfer that value right into this box, and we see, okay, all of these words now have a value. So this is the end of SHA-1 round 0, and we're now going to be setting these values to be the new values up top. Previously, we said that this is word 1 round 1, word 2 round 1, etc. So now we're going to replace these top banners, you know, with word 1 round 1, and just transfer the values up here. And now we're kind of going to be resetting the scene with these new values up top. Basically, we're set up for a new round now, and we're going to be running the same process again. So instead of stepping through this for all 80 rounds, I'm going to kind of show off the round increase here. So you can see, like, here, I'll just play it fast, really quick. So you can see we're going through the exact same process here. F-box, addition, left bit rotation. You can even speed it up more. You know, etc. Filling these out, and they transfer, and it's going to repeat over and over again. All right, so I'll stop it there, and I'm going to be stepping through the rounds now. So, you know, end of round 4, 5, and we can see the message schedule here has now updated to be for round 4 through 7. Keep on stepping through. Now that we're on round 20, the F function changes here to be W2 XOR W3 XOR W4, and the round constant here is going to change to be 6e instead. So I'll just show the F function really quick here, and you can see we're taking in the bytes, translating them into bits, taking the XOR, and then, you know, taking the W4 byte as well, going to bit XOR, and then we get our output eventually here. So just step through really fast, and we get this value. Here's if we restart, it goes back to the first frame there. All right, so I'm just going to continue stepping through the rounds until eventually we get to the end. Takes a little while, but all right, so finally we're on round 79, and that means that we've gone through, we're at the end of round 79, so that means we've stepped through every round, and that's the end of SHA-1. So our output hash is actually just the concatenation of these boxes on top here. So that is about it for the SHA-1 visualization. I hope you enjoyed the video and that it was informational.